Question 6, it says, in the diagram, the graph of f of x is equal to cos 2x is drawn for the interval where x is between minus 270 degrees to 90 degrees. 6.1 wants us to draw the graph of g of x that is equals to 2 sine x minus 1 for the interval between minus 270 degrees to 90 degrees. On the grid that's given in the answer book, so in the answer book, they just give the graph as is, and we need to draw on top of that. So we need to show all the intercepts with the x-axis as well as the turning points. Now let's consider a function. Let's name it something else. H of x, and h of x is equals to sine of x. Right, for the normal sine of x, we expect that at 90, it would be at 1. At 0, it would be at 0. At negative 90, it would be at negative 1. And minus 180, it will be at 0. And at negative 270, we will get a positive 1. Let's go and increase the amplitude of our graph. Let's call this k of x, which is going to be 2 of h of x. So we'll just write it as 2 sine x. So what happens now is that we're stretching out our graph. So each point needs to be multiplied by the new amplitude. So that multiplied by 2 will give us 2. 0 multiplied by 2 will give us 0. Negative 1 multiplied by 2 will give us a negative 2. 0 multiplied by 2 will give us 0. Positive 1 multiplied by 2 will give us 2. Then we get to our g of x, which is equals to our k of x minus 1. So we'll have 2 sine x minus 1. What we will do to those points, we will move them 1 point lower. So what used to be 2 will then become 1. What used to be 0 will become negative 1. What used to be negative 2 will become negative 3. What used to be a 0 will become a negative 1. And what used to be a positive 2 will become a positive 1. So again, we can connect the dots for our function. And, this is what our function is going to look like. We can go ahead on our graph and show our turning point. There's our first turning point, which is negative 90 and minus 3. Okay, we have another turning point over there, 90 and 1. And another turning point over there, minus and 1. We need these points where we cut our x-axis. This is where your x-intercept, this is where your g of x is equal to 0. So we'll have 2 sine x minus 1 is equals to 0. We'll have sine x is equals to 1 over 2. So we'll have a reference angle, which will be equals to 30 degrees. Sine is positive in the first quadrant, so we'll have x is equals to 30 plus k 360. And if we allow that k 360 to be equal to 0, we get x is equals to 30, which is this point over here. And it's also positive in the second quadrant, and that's going to give us x is equals to 180 minus 30 plus k 360. and that's going to give us 150 plus K360. And if our K is equals to -1, our X will be equal to a -210, which is that point over there. So another way we can do it, we can just plug in the equation into your calculator and get points back. Let's see how we do that. Calculator, you would just say go to mode and then go to table. You can draw in your graph there. You say 2 sine, you press alpha, x, and then close your bracket. Then you say subtract 1. Then you say equals 2. You don't have a g of x, so you can pass that. And you want to start at a -217. And you want to end at 90. And you want to take steps of 30. And voila, there is all the points you need to plot.